Last but not least is Taylor Merkel. Taylor's talk is called The Improbability of Life, Why We Shouldn't Exist. Taylor is a prospective bio major from Chicago, Indiana. Her main interests include red lipstick, cats, and, as you'll soon learn, genetics and impossible questions. Taylor.
All right, thank you for that. Okay, so let me take you guys back to the Big Bang. All of the mass in the universe was confined to one infinitesimally small speck. All the atoms that would eventually make up the earth we walk on, the air we breathe, you and me, and I guess any sort of beverages you might have regretted and or enjoyed last weekend. Stuff like that. So from that moment to this, think about how many things that could have gone differently for us not to exist. You consider the formation of the earth with precisely the right conditions to sustain life, and the sheer complexity of that life. Also, the seemingly flagrant violation of thermodynamics that our existence causes. In short, how the hell are we here? So first off, the Earth is located in what's called the Goldilocks zone of the sun. So, not too hot, not too cold, just right. More technically, this is called the circumstellar habitable zone, which means that it's the region around a star in which liquid water can exist. And liquid water is a prerequisite for carbon-based life, which, you and me. So this means that if the Earth were shifted a few million miles in any direction, which is really not that much in the universal scale of things, then we couldn't exist. We would not have that water to sustain life. Earth is also pretty much the perfect size to sustain life. If it were any bigger, the gravity would be too strong, the atmosphere would be too thick, and Earth would be a scalding gas giant and boil us all alive. Any smaller, gravity wouldn't be strong enough to hold onto the atmosphere. We wouldn't have any protection from radiation or enough air to breathe. Even things like the presence of the moon make a huge difference in creating the perfect conditions for life. There's hypotheses that the generation of tides by the moon kind of set the stage for life to start evolving to survive on land as opposed to water. So speaking of evolution, that's just a whole other area where things could have gone terribly wrong. And that's wrong in the egotistical sense that we wouldn't exist. So we theorize that life originated in a sort of primordial soup. So some of you might have heard this term before. So this is theoretically like a solution containing small molecules that were present in the early Earth atmosphere. So it would be things like carbon dioxide, nitrogen gas, perhaps ammonia or methane. We can't really know for sure. So experiments have shown that a strong electrical current, like you would get from a bolt of lightning, can spur reactions in this soup that create small organic molecules, which create life, eventually. So an experiment showed that electricity could create amino acids. These create proteins, which eventually create you and me. So this seems feasible enough, this reaction that can occur. But when you start to think about the way that amino acids would have to combine in very long, unique sequences to form polypeptides, that these polypeptides would have to fold up into specific conformations to create proteins, and that these proteins would have to be taken up in some sort of cell membrane just to create some very prototypical life. Things get a little bit more unbelievable. So even if we just assume that all of this magically worked out and we ended up with simple single-celled organisms, you still have to account for 3.5 billion years of accrued mutations and evolution to bring us where we are today. It's a lot to fathom. And not to mention that our very existence seems to defy thermodynamics. So the second law of thermodynamics states that entropy, the disorder of the universe, is constantly increasing. So think of this as a law that any structure will tend to assume its most probable conformation. So for example, think of 5 bricks, right? If you were to stack these vertically, you've got around 120, that's like 5 factorial ways to stack these. But if you were to assume that you wanted to lay them on the ground horizontally, you've got a much greater number of ways to do this. You can flip them, you can rotate them, like they're just laying on the ground. And so intuitively, we see this as the more disordered conformation. But life, on the other hand, tends towards order. Like humans, we love to stack things, right? And even simpler organisms like, ants, for example, will create ordered structures, anthills. Organisms themselves are also inherently ordered. If we weren't, we'd be piles of organic mush and water, and nobody wants that. So that's like yet another strike against our very existence. But before you spiral into any sort of existential crisis, I should tell you that perhaps the title of my talk is a bit misleading, because there are potential explanations for how life persists. So, for example, one physicist at MIT has proposed that living organisms evolved to be self-replicating energy wasters, basically. So the laws of the universe say that we have to increase disorder, and in a way, humans, life, we do this, because the more evolved an organism is, the less efficiently it uses energy. So think plants, they take sunlight and they make a lot of food. We just eat the plants and we're wasting a lot, we just generate heat. And so we may have evolved just to evolve to waste just as much energy as possible. And so some people also opt for the belief that, you know, there's some sort of higher power, something that created us this way, and that it's not just a fluke. But then again, maybe it is. It could just be sheer luck that we beat the odds to be here. So really, there's no way, no perfect way to definitively justify why we're here. I guess I like to think of it, our lives, our consciousness, as stolen hours in a way. So I guess I'll leave you with the question that what are you going to do to make the most of it?